everyone, welcome back to my channel EduVibe. Today we will start with the practice question of the forces and fields. This is basically from the electric fields part. So we completed a part in the previous lesson. Today we're doing the practice question of that lesson. Then we'll move on to the last part of this chapter, which is the magnetism. So let's start with the first question. When a proton is placed within an electric field, it experiences the electrostatic force of 3.6 into 10 raised to minus 13 Newton south. An electron is then placed in the same location. Determine the acceleration of the electron. So we have to find the acceleration of the electron, but they given us the proton's electrostatic force. They also say that the electron is then placed in the same location as the proton is it. So for this type of question, we firstly focus on the proton. We have a proton's electrostatic force. So proton's electrostatic force, and if we find the electric field of the proton, if we feel the electric field of the proton from here, we can find the electron's acceleration. So how can we find? Well, firstly we have to find the electric field of the proton. So the electrostatic force is equal to Q times electric field. So from here, the electric field is equal to Fe divided by Q. So the electric field is equal to Fe has the value of 3.6 into 10 raised to power minus 13 newtons divided by Q. Q of the proton. So Q of the proton is 1e. So 1e means like elementary charge. So this means this is 1.60 to 10 raised to minus 19 coulombs. So from here you can find the electric field. So you get 2287500 Newton per coulombs. So that's the electric field of the proton. Also, you know that the net force is equal to the electrostatic force. So from here, if the net force is mass into acceleration, and this is equal to Q times electric field. So the acceleration is equal to Q times electric field divided by the mass. So this is all now about the electron. So electron's force is 1.6 into 10 raised to minus 19 coulombs. Electric field we already find, which is this, and the mass of the electron is 9.11 to 10 raised to minus 31 kgs. So from here, what is acceleration? You have to multiply, you have to divide. So you get 4.02 into 10 raised to power 17 meter per second square. So that's the acceleration of the electron we have to find. Yeah, this is the answer for that question. Next question, we have this question. The question says the battery is attached to two parallel metal plates and the plates are separated by 6.00 mm to produce an electric field strength of 800 volt per meter. So this is the battery attached to this, and we have this. So remind the electric field strength if the plates are moved to a separation distance of 2.0 mm. They are the two cases. They are the depend on the two cases we have. So first case, we have a two parallel metal plates and they are separated by 6.0 mm and have the electric field strength of the 800 volt per meter. Then we have to find the electric field which has now moved to a separation distance of the 2.0 mm. So that at that separation distance, what is the electric field of that thing? So we know that the electric field is equal to delta V upon delta D. So both so what's the common in that case? The battery. So the battery in both the cases is the same. When we have a 6.0 mm, we have the same battery, and that same battery is attached to the parallel plates when we move on to the 2.00 mm. So this means that delta V remains the same. So if delta V is equal to for E1 and delta D1, and if this is constant and if the other one is also this means E2. So we are both equal to delta V. If we're both equal to delta V, so this means they both are equal to each other. And we have to find the electric field for the second one when it goes to 2.0 mm. So we have to find the E2. So E1 times delta D1 divided by delta D2. So we have to put the values in. E1 is 800 volt per meter. Delta D1 is 6.00 mm. Divided by delta D2 is 2.00 mm. That mm cancel out. When you calculate this, you get about 2.40 into 10 raised to power 3 volt meters. So that's how you can find when we have a two types of cases with the same type of battery for the pilot based questions. Let's move on to the next one. This one. So what says that we have a for the diagram shown, the magnitude of the electric field between the plates is 4.81 into 10 raised to power 4 Newton coulombs. We have electric field of the magnitude of this plate system. We have to find the speed of the particle when it hits the opposite. So we have to find that alpha particle's speed when it hits the this plate. So for this, we have to find something. So basically, we have to find the speed of the if this is A and this is B, so we have to find the speed of the B, means we have to find the VB. And at that case, what is our voltage? At the starting, our voltage is 0 because it starts from there. So it's the voltage at that case is 0. It enters from here. At that point, they have some kind of voltage they have. So at that case, we have that VA over there, which is the initial speed of this. But that VB we have to find. How can we find? Because we know that electric field is equal to delta V upon delta D. So delta V is equal to electric field times delta D. Electric field we have to given, we already given 4.81 10 raised to power 4 Newton coulombs. And the separation distance is this, which is 12.0 centimeters, which is in meters is 0.120 meters. From here, your delta V is 5772 volts. So we get at this, which is 5772 volts. So now our main focus is to find that VB. So how can we find that? So we know that conservation of energy formula, which is the EKA plus EPA is equal to EKB plus EPB. So that's the thing. At the starting, our voltage is 0. So that means this goes to 0. Everything we have in this. So we have to do odd things. So this is half MA square, MVA square. EKB is half MVB square plus QVB. So basically we have to find that VB square. So you can see our half over there. If we divide this by whole thing by 2, you get that this goes to the top and this goes the 2 value in the front. So this means V MVA square is equal to MVB square plus 2QVB. So that's the thing we get. We find that VB. So we have to isolate this. So VB is equal to MVA square minus 2QVB divided by the mass. This whole thing. We are at the root. So for VB, the mass. So the mass we have to take for the alpha particle. Alpha mass is given to in your data sheet, which is 6.65 into 10 raised to power minus 27 kgs. VA square you already given to us, which is this, which is 7.80 multiplied by 10 raised to power 5 meter per second whole square minus 2. Then Q is the also the alpha particles charge. Alpha particle has the charge of 2 electron 2e. E is elementary charge, so it says multiply by elementary charge. So we get 3.20 10 raised to minus 19 coulombs. And the last we already find this voltage for B, which is 5772 volt. Divide this whole by the mass of the earth particle. So now, and this whole root. So now you have to solve this, and when you solve this, you get about 2.30 into 10 raised to power 5 meter per second. So this you get when you find the VV, which is the speed of particle when it hits the opposite plate, which is that. So that's how you can find. This is how you can solve this question when the any charge is in move into the parallel planes. So that's how you can deal with those. So let's move on to the next one. This one. Okay. So in this is a different kind of question. So make sure you have like good understanding of that question, because you get that question like often in the examination or sometimes in the diploma too. So first question says the beam of alpha particle is then on the region containing on the uniform electric field of 2000 volt per meter as shown below, while in the electric field the particle accelerates towards the top plate. So it goes to the like top plate like this, and this has the alpha particle again. So you have to label the probability of the plates. Based on your measurements, determine the potential difference between the plates and initial horizontal speed of the particles entering between the plates. And note that you will have to make your own measurements on this diagram. So you can see that you have nothing in this diagram which is measured. So we have to measure our own things. We have to measure this thing with the help of scale, with the help of ruler. So you get that ruler, and basically what you have to find that means that over there you can see your alpha particle is over there and it moves towards this. This is kind of the question when we do the uniform motion and we can do the accelerated motion. So that's the table we have to make. So firstly, before doing the measurements, then what type of measurements we need, so we have to make that thing, which is S uniform motion, and the Y, which is accelerated motion. So here we have delta dx. So we have to find the horizontal speed of the alpha particles. So horizontal speed of our particles means we have to find the Vx. So this we have to find, and then time is not there. For dy, we don't know yet. For t, for time we have to find Viy in that case is remains 0 meter per second. And if we want acceleration, yeah, we want acceleration because we want to find the Vx, so we want acceleration too. Fine. So for dx and dy, we already have those. How? So with the help of scale, we have. So this one we have to measure. This one we have to measure. And for the finding the potential difference, we want the delta d, which is the separation distance between the two plates. So we also have to find this. So this is your delta dx, this is your delta dy, and this is your delta d. So to find this, you have the scale. Okay, so this is at 0 until that arrow you have to find. So it's basically the 4, which is 4.00 centimeters. So this means from here to here you have 4.00 centimeters, which is in meters, which is 0.040 meters. So also same with that thing. So something you get about 1.1 in that case. So from here to here you get 1.1 centimeters, which is in meters, which is 0.011 meters. And the last you have to find this too. So from here to here you get something about 2.0. So from here to here you get 2.0 centimeters, which is in meters, which is 0.020 meters. So that's all the elements you have to make. And from that case, that goes that alpha particle goes to alpha t is in positive. So this means this is alpha 2 plus, and it goes up. This means that up plate is your negative one and the down plate is your positive one. So this is the polarity we have to label on that table. So that the A part we have already done. We have to do the B part, the first and second part for B. So basically what we have to find, so now we have that dx, which is 0.040 meters, and this is 0.011 meters. So for basically we have to find a potential difference. So for potential distance, this is equal to delta V upon delta D. Delta V is electric field times delta D. So electric field is 2000 volt per meter is given to you. Delta D we already measured, which is this. When you Multiply this, you get about 40 volts. So this is your delta V we have to find. So for the second part now, we have to find the horizontal speed, which is that Vx. So for Vx, first we want the acceleration. Acceleration we want for time, and the time we want for Vx. So let's find the acceleration first. So we know that the net force is equal to the electrostatic force. Net force is m times acceleration, and this is q times electric field. We want that acceleration at y, so it's y, which is q times electric field divided by mass. So for acceleration at the y, we have q of alpha particle, which is 3.20 × 10 raised to minus 19 coulombs. For electric field, we already given to us, which is 2000 volt per meter, divided by the mass of the alpha particle, which is 6.65 into 10 raised to power minus 27 kgs. When you calculate this, you get about the 9.624 into 10 raised to power 10 meter per second scale. So that's how you can find the acceleration. Acceleration we want for the time. So delta dy is equal to viy t plus half at square. That can this goes to 0 because we have vi y is 0. For that t, we mean that this is delta t, or you can say just as it t, which is equal to this two rows over there, 2 dy divided by ay. That's all you done in when we do this sum. So you all know that this is all other kinematic equations we do, and this is an easy thing, we all done this. So dy we know is 0.011 meters divided by 9.24 into 10 raised to the power 10 meter per second square. That is acceleration. And when you solve this time over there, I tell you that the time is you get is 4.7811 into 10 raised to power minus 7 seconds. So that's the time you get. But you want the Vx. Vx is equal to delta dx upon time. So Vs is equal to delta dx you already have, which is 0.040 meters. We measure that. Time you find. And when you calculate this, you get about 8.4 into 10 raised to power 4 meter per second. 1 2 this. So that's all thing you have to do to get the Vs, which is the horizontal speed of water and film between the plates. So that's how you can do that question. This is like you already done this in grade 11 physics when you do the projectile motion, the horizontal or non-horizontal one. So this is kind of the that topic with the electric field stuff. So that's all what you have to do. And yeah. So let's move on to the last question of this lesson today. So this question, I told you that when you do one formula for anything, you get the one graphical analysis question from that topic. So that's the question we get. This is from the Macauliffe oil drop experiment. So when we do the Fe plus Fg, which is equal to net force, so that's the thing we have to do in this with the graphical analysis. So let's do this. They mentioned that the charged particles of varying masses suspended between the two parallel plates separated by the distance of 0.050 meter in Milkins type experiment. Graph showing potential difference as a function of the mass of the charged particles is shown below. Use the slope of the line of best fitted, determine the charge on the all drops, and give an answer to the two significant units. So basically what they tell us that we have the potential difference over there on the y-axis, and on the x-axis we have the mass. So that's the two things we have. So in that case too, we have this free body diagram like of thing. We have Fg over there, we have Fe over there. So this is your free body diagram. And in that case, they mention that there is a suspended. In every question, in any question, you get the suspended word. This means that net force is goes to 0. The net force goes to 0. So in that case, net force goes to 0. So if net force is equal to Fe plus Fg, in that case, your Fe goes to equal to Fg. So your F is equal to Fg. Fe you have Q times electric field is equal to mg. So now you want the slope from here. So you know that your potential for delta V, you have that potential difference here, which is delta V. So you have to be in the equation too. So you all know that the electric field is equal to delta V upon delta D is equal to mass times gravitational force. And your delta V is in the y-axis, so delta V remains over there, and the rest of the all thing goes to that side, which is this divided by Q. So now your mass is always goes to the x-axis, so it goes to out from there. So this goes to out from here to get the mass as x-axis. So this is all what you have to show now. So G delta D upon Q, this whole multiplied by M. This is the same thing like this. So now this is your y-axis, this is your x-axis, and this is your slope for this graph. So you know you want the slope. So you know the slope is equal to now G delta D upon Q. So what you want to find, you have to find the charge of this. So to find the charge, that Q is equal to what? G delta D divided by slope. The delta D you already have, G you know 9.81, and you have to find the slope. So let's find the slope first. Slope is equal to y2 minus y1 upon x2 minus x1. So you want the 2 points which are just like a z points you have in the graph, like approximation will occur in this. You have to make the approximation. So for the 2 points you have to do like the graph, and I see that point over there, which is over there. This is the point. I see this is like the tying of a z point but not like a z point. So I take that point which is about 1.6 and into 10 raised to power minus 14 kgs we have over there. So we have to make that units n. And the other thing, this is approximately 22 24.0 volt. So that's like that. So that's all approximation part. You get a more accurate graph in the questions when you do in the examination. So yeah, so this is like the approximation you will have to do in this now. The next point I'll get over there, like this point. I think this point is like that the this point I get over there. So this is the point which is 7.8 10 raised to minus 14 kgs, comma, which is 114.0 volt, I think. So this is again approximation I do. So from here, this is your x1 y1 and this is your x2 y2. Now this you have to put in this graph. So 114.0 volt minus 24.0 volt divided by raised to 7.8 into 10 raised to minus 14 kgs minus 1.6 into 10 raised to minus 14 kgs. So from here, when you calculate this and you divide this, you get a slope of 1.4839 into 10 raised to power 15 volt per kg you get in that case. So that's the slope. So now you have to put this in n. So Q is equal to 9.8 meter per second square. Delta D you have over there 0.050 meters divided by this whole slope. So when you calculate this, you get about 3.3 into 10 raised to power minus 16 coulombs. Again, this is like not a exact answer. This is an approximation value. So if you get the 3.4, 3.5, 2.9, that's all are the right answers, because depend on that graph, you get the any point from there. So this all depends on you, what points you get from that graph. So that's all you have to do in that type of questions. So that's all for this lesson. That's all for this practice question of the electric fields. We do much more questions when we do diploma questions of this unit. So for now, that's then. So in the next lesson, we'll start with the magnetism, introduction to magnetism first we do. So yeah, so learning myself I do vibe, learn smarter but not harder. Please like, share, and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till then, stay careful with EduVibe.